So good evening.
So good evening. So good evening. Yeah, hi. Good evening, Debaran Banerjee.
So welcome to the live session of this particular NPTEL course, Waste to Energy Conversion. My name is Devarun Banerjee of Indian Institute of Technology, Delhi. So in this week's lecture, the first lecture was about the power generation process. Basically, uh, the energy efficiency improvement of power plants were discussed. So energy analysis of the steam process. Types of turbines and the cycles for power generation, working of combined cycle and efficiency improvement, and efficiency calculation through thermodynamic laws. So these are the topics which are covered in the first lecture. Let us quickly check what were discussed. So basically the basic energy analysis of a steam process are discussed, where in a boiler basically the steam generation is done, where energy input is given uh, in terms of fuel, and along with that air is given, and through the steam generation we get a certain energy output. Along with that we get a certain steam obviously at a high pressure. Okay. uh, So in this particular steam generator, there is always some energy losses are there. Basically, when you are calculating the energy output, need to consider this particular energy losses also to balance with the energy input. Uh, Therefore, the useful energy calculations. So the useful energy calculation, it takes care of the basically the steam generation rate. This kind of formula is there, which is Ws by Wf, steam generation rate divided by the fuel burning rate multiplied by H2 minus H1, which is the enthalpy of steam after the evaporator, and H1 is the enthalpy of feed water before the economizer, plus 1 minus M1. Okay. So the M1 is the mass fraction of inlet steam from high pressure turbine, and H4 minus H3 the enthalpy of steam after superheater, and enthalpy of steam before superheater. So that particular energy enthalpy differences, uh, those you have to this kind of formula you have to use to get the useful energy calculation. Uh, so the total energy is also another important factor. So the total energy is basically the energy released in complete combustion of 1 kg of fuel, which is equals to the higher heating value of the wastes or fuel. So wastes are basically used as a fuel in this particular area of waste to energy conversion. So when you're talking about the useful energy, so you need to subtract the energy losses from this higher heating value. On a different note, we can talk about like the higher heating value equals to the useful energy plus energy losses. Okay. So what are the different forms of energy losses? The energy losses include the energy loss due to moisture in waste, energy loss due to hydrogen in waste, uh, carbon due to a dry exhaust gas due to incomplete combustion. So there are this kind of different multiple types of energy losses can be happening. and depending on the particular situation and the practical scenario, those calculations needs to be taken care of. And the computation of the different energy losses, such as one different examples are shown, different like empirical formulas. Q2 is the energy loss due to the moisture present. Okay, so which is basically you can obtain by this m into 4.187, which is the specific heat, into 100 minus Ta plus 2256.8 plus 2.09 Tg minus 0. So there are this kind of different empirical formulas are there, which might not be very important for memorizing, but get an idea of how to compute the energy losses. Similarly, the energy loss due to dry exhaust gas Q5 is also given as the mass of dry exhaust gas is simply similar like MCP/dT. We know the formula of particular energy difference. So M is here the mass of dry exhaust gas produced per kg of fuel. Cp is the average specific heat of the dry exhaust gas. Delta T is basically this exhaust gas temperature and ambient temperature difference. Okay. Similarly, uh, the energy loss due to incomplete combustion, which is basically when incomplete combustion happens, the carbon is converted to CO, not to the CO2, right? So that is why this particular the loss of energy per kg of carbon oxidized to CO is 0.000 divided by 12. This uh, 12 is the atomic number of the atomic mass of the carbon. The energy loss due to the convection and radiation from boiler surface. This is also another formula. Q7 equals to the Hc plus Hr, which are basically the convective and radiative multiplied by the total surface area multiplied by the delta T. And also the energy loss due to the moisture coming with the air supplied is specific humidity of air multiplied by the amount of air used per kg of fuel into Cp delta T. The energy loss due to the ash and slag Q9, basically the difference of the carbon absorbed and the carbon present in your particular material. With this, the efficiency of steam generator is also important. So for the efficiency calculation, you need to take of the useful energy. So it means that this kind of different forms we need to take care, and the useful energy is higher heating value minus summation of these different energy losses. So the efficiency of steam generator is basically like Q1 divided by higher heating value. The types of turbines and cycles used for power generation. The different types are basically the steam turbine, which works upon the steam turbine, the gas turbine to work basically based on the gas turbine cycle, and there is a combined cycle, which is the both gas and steam turbines. The steam turbine cycle basically uh, for energy generation, there is a fuel in the boiler. From the boiler, steam is generated, which comes to the turbine, in which the power. So water is pumped into the boiler, and the fuel is used to generate the steam inside the boiler, which is exhaust from the incinerator, the fuel. So after that, the high pressure steam produced from the boiler is passed through the turbine, and it generates electricity. So in this particular boiler, steam is generated. The steam is fed into turbine, is generated, and then from the turbine, uh, there is a exhaust stream which is sent to the condenser, where basically the from the vapor phase it is condensed, and then it is recycled to the boiler through a pump, where again the steam generation takes place. The gas turbine cycle, what it is, basically the fresh air is compressed and sent to the combustion chamber along with the fuel. So in pressure, the through high pressure, there is a compression occurs on the fresh air. That compressed air along with the fuel, it goes to the combustion chamber. The exhaust gas from the combustion chamber is directly sent to the gas turbine. So in the combustion is happening at a very high temperature, about 1500 to 1800 degrees Celsius. The exhaust gas from the combustion is directly sent to the turbine for the generation of electricity, which means that it is operated. So which means that the efficiency or the uh, amount of electricity generation per unit of the mass of the fuel given, that might be different compared to the steam turbine. And there is then the combined steam and gas turbine cycle, where these individual two cycles are happening. One is the gas turbine cycle in this bottom part, and the top part is the steam turbine cycle. So why this particular combined cycle is important? So basically, as I talked about the efficiency, so to get an improved efficiency, so for the improvement of the efficiency, this particular combined cycle is important. So in this particular combined cycle, what happens is the exhaust gas from incinerator is passed through the gas turbine. The gas turbine exhaust at a lower temperature is sent to the boiler, and then the steam which is produced in the boiler is passed through the steam turbine. Gas turbine works, and then the steam turbine works. Okay. An important thing is that in the gas turbine, you see the exhaust gas from the gas turbine is usually released, is basically wasted. But in this particular combined cycle, the exhaust from the gas turbine is not wasted. Instead, it is sent to the boiler for the waste heat recovery. The quantity of electricity generated is increased as it is produced in two stages, which means that fuel you are giving, it is giving, so it is generating uh, much more amount of electricity per unit of fuel feed is given. So obviously the efficiency of the overall system is increased in case of a combined cycle. Based on that, through various thermodynamic laws, through first law and second law, you can calculate the efficiency of this kind of thermodynamic system. Okay, and it is shown like various via the net energy production ratios. You can basically calculate the efficiency, and which can be actually calculated via the first law of thermodynamics and the second law of the thermodynamics. Okay. So first question of today, the useful energy indicates the energy available in the produced steam. So the useful energy indicates the energy available in the produced steam. which depends on steam generation rate, waste or fuel burning rate, temperature and pressure of the steam, or all of the above. So let us see. So basically the correct answer is D, all of the above. So the useful energy, which is basically the higher rating value, and subtracting the energy losses, it indicates the energy available in the produced steam. So basically, ultimately, what is the usable energy which you are getting from a particular this kind of operation? So it is a factor of steam generation rate, the fuel burning rate, temperature pressure of the steam, mass fraction of inlet steam from the high pressure turbine before reheating. So these are all possible really can affect the useful energy. So all of the above is the correct answer. So useful energy of the steam process in a boiler can be calculated by useful energy equals to higher heating value minus energy losses equals to higher heating value plus energy losses equals to higher heating value minus lower heating value, or it's addition of higher heating value. So the correct answer is A. Useful energy equals to the higher rating value minus energy losses. So the total energy, which is it is basically the theoretical value of a fuel which has it's the higher heating value or the gross calorific value. So you need to subtract the losses of the include this type of different losses which I have briefly discussed. You can go through the detailed lecture slides. So this type of different losses are there. So if you want to subtract these losses from the higher rating value, you will be getting the useful energy. So after that, there are the two lectures which are based on the plastic wastes. So the content plastics, their classification and codes for recyclable plastics, the types of plastic and their monomers, their suitability for energy production, plastic wastes generation and its need for proper management, options for management of plastic wastes, and recycling through pyrolysis. Then basically the details of the plastic pyrolysis, the reaction mechanism, process types, and the variables, catalytic pyrolysis, basic. Uh, then typical process flow sheet for the waste plastic pyrolysis, different reactors for pyrolysis, and basic some case studies and international and national scenario energy production from plastic wastes. So let us see quickly what has been covered. So basically, plastic is a material consisting of any of a wide range of synthetic or semi-synthetic organs that are malleable and can be molded into solid objects. So plastics are typically organic polymers which have a high molecular weight, but they often contain other substances such as fillers, plasticizers, colorants, like that, to give that particular shape and particular properties, particular color things. What are the importance of these other substances? Fillers improve the performance and reduce the production costs. Plasticizers are oily compounds which confer improved rheology, and colorants are common additives, although their weight contribution is very small. Okay, but it is also important to note that this kind of different additives which can also be toxic. So nowadays you also might be knowing that uh, uh, there is a basically very much encouragement towards a green plastic or those kind of things. So this kind of toxicity is generally needs to be avoided because plastic is overall a organic material and also this kind of biodegradable plastic. So those kind of things are very much encouraged and very heavily researched upon. So the two types of plastics generally we know, thermoplastic and thermostatic. Thermoplastics are which are not undergoes certain chemical change when they are heated. Okay, so basically, but the thermosets what happens is they do get melted and they take shape once. Okay, so the thing is that thermoplastics you can is basically a reversible kind of thing, but thermosetting is, as the name is suggesting, it sets itself at that particular with a particular shape. So if you give a particular heating or thermoset polymers, they get melt and they take a particular shape. After that, even you withdraw this particular thermal energy or temperature, you cannot get back its original uh, uh, shape. Okay, that is one of the problem. So there is a typical different plastics such as PET, HDPE, PVC, so LDP like this high density polyethylene, PVC is polyvinyl chloride, and they are different typical examples. So you might check the lecture slides. basically for this kind of, these are basic, very basic theoretical things, right? So PVC, LDPE, polypropylene, polystyrene, these are the different types of plastics. And further, the different types of plastics and their monomers are also shown here, like polyethylene, polypropylene, polyvinyl chloride, PVC, PET, polystyrene, and then also polycarbonate, which has a monomer like organic functional groups linked together by carbonate groups. So basically, as the name suggests, polycarbonate. So there will be multiple this kind of carbonate. You can see from this formula, there is a CO3 group is there. So this CO3 group will be repeated and repeated multiple times. That's how the polymer is formed. ABS you might know, like acrylonitrile butadiene styrene. So as the name suggests, these three are basically three monomer units, and together they form the, then with this particular monomer unit, this acrylonitrile, butadiene, and styrene, these three together form a one monomer unit of this particular uh, polymer. Then there is this particular entire monomer unit would be repeated to form this ABS. Nylon 66. Uh, these are also some other examples. So the suitability of plastic types, you see polyethylene, polypropylene, polystyrene. These are basically very good fuel properties they have. On the other hand, if you see the PVC, polyurethane or PET, these are not very much suitable for the fuel purpose, okay, for energy production. And that is why this particular like PVC, uh, fiber reinforced plastics, these are not very much used in energy production, rather than these are used for generating some other products. Some useful products are made from this kind of plastics. Some basic data, as with the increase in population, with the increase in modernization, the more and more plastic waste generation is also getting increased. This data up to 2014, this data is shown, but still obviously the trend is going on and upwards. So that is why the proper management of this particular plastic waste are important. So majority of the plastic waste, about 80% is the polypropylene, polyethylene, this kind of plastics. About 20% are the ABS, melamine, polycarbonate, thermocol, like this. Okay, so some more data are like 120,000 W is generated in India, and 10,000 tons per day plastic waste in our country, which is generated. So roughly about 9 to 10% of the MSW is about the only the plastics. So this is such a huge, a problem. In India, the waste plastics form widespread littering on the landscape due to the lack of proper management techniques. Around 8 million tons of plastic waste are dumped in the ocean each year, so causing various, environmental. And obviously these plastics are not biodegradable, so years and years after they stay in that particular form, similar form, and therefore basically they create a very much environmental problems. In spite of the above facts, due to user friendly nature, ban of plastics could not succeed in India, obviously. Though we try to use this kind of paper things or cardboard things, still the plastics is very much user friendly thing if we keep aside for one time the environmental aspect, because it is lightweight, it is durable, it is energy efficient, it is hydrophobic kind of in nature, right? uh, Therefore the biodegradable kind of plastic, green plastics, these are basically nowadays very much focused upon. And pyrolysis is a cost-effective process and is applied for the waste plastic or waste tire management and being investigated to decrease this kind of amount of the like this 8 million tons of plastic waste per annum to decrease this amount of the plastic waste. Okay, so basically we can have a liquid fuel production, some plasma gasification, and also this plastic coated bitumen for road construction. These are all some of the options. Apart from that, some recycling options are there, which are divided into again primary. Okay, so pyrolysis is, as said, one of the very important options to utilize the waste plastic. So by pyrolysis, you can have solid, liquid, gas, three types of products. The liquid can actually be of very much useful as a fuel, like LPG products, like olefins, waxes. These kind of products are can be obtained from the liquid part. The gas can be used for the heat application. The solid can be used for the carbon nanotube kind of production. Okay. Uh, so basic the reaction mechanism to see is basically kind of a free radical mechanism which happens for the plastic pyrolysis based on the chain initiation, then propagation, and then some hydrogen transfer, intramolecular hydrogen transfer occurs, and they have the different k values, and depending upon the scenario, depending upon the no, the thermodynamic condition, depending upon the catalyst, those will be actually varied, and you will be getting different k values, and from that also the activation energies and the uh, pre-exponential factors which you can use to model your particular reaction of this particular. Okay, so let's move to another question. Lunch boxes, margarine containers, yogurt pots, syrup bottles, plastic bottles. These are typical examples of products which can be produced from low density polyethylene, polypropylene, polystyrene, polyvinyl chloride. So B, polypropylene is the correct answer. So if you see this particular list, polypropylene is which is used to produce the lunch boxes, margarine containers, all these which are shown in here particular question. These different types of bottles, bottle caps, lunch boxes like that containers. Polystyrene is used for coffee cups, food boxes, plastic cutlery, packing foam, all those things. Low density polyethylene for usually the bags, like sandwich bags, plastic grocery bag, clean, like that. And chloride. These are basically you all know PVC pipes and ties. So these are the answers. Match the following with different types of plastics with their monomer. So LDP, polypropylene, polystyrene. The monomers are ethylene, styrene, propylene. So it's very easy, just by the name suggests. So polyethylene, obviously the monomer is ethylene, polypropylene, propylene as the monomer, and polystyrene as the styrene as the monomer. Now a simple numerical problem. In a laboratory, 100 gram of waste plastic sample is pyrolyzed in a batch reactor having a weight of 250 grams is 35 grams and the final weight of reactor is 255 grams. You have to calculate the yield of solid, liquid and gas fractions. So the correct answer is D. So very simple. The liquid weight percent is basically the weight of liquid divided by feed weight into 100, and solid is similar, weight of solid divided by weight of feed into 100, and gas is basically the both of them. Okay, so the liquid weight is given 35 grams. Our feed was 100 grams, so basically 35% is the liquid. So the solid was, which was the residue. So you can get it from by subtraction of the final weight of reactor and initial weight of reactor. Finally, it was 255 grams, and initially the batch reactor was 250 grams. So basically, 5 grams was the solid residue after pyrolysis. 5 upon 100 was the feed, so it's 5%. And if you just subtract by adding both of them, 100 minus 35 plus 5, it's coming 60% as the gas weight percent. Okay, and the second part of the waste plastics uh, conversion. So basically the pyrolysis has been discussed. So basic typical pyrolysis process flow is you give the feed after a certain size reduction or this kind of pre-treatments processes, and also when it's talking about the plastic, so you have to give it by melting it. So by providing heat by a preheater, you melt it, provide it in the pyrolysis as a melt feed, and after the pyrolysis there is some further post actions needs to be taken, such as distillation and some gas scrubbing. All those different unit operations are there, and after distillation we get different carbon ranges products. The solid part is the carbon char in the directly from pyrolysis we get. After that we can via distillation based on this uh, separation, the gasoline, kerosene, waxes, naphtha, diesel, these kind of different ranges of products we can get. And some typical melting point of these different plastics are shown here because we have to give the melt feed. So polypropylene has a lower melting point, about 130 to 170 degrees Celsius. Polyethylene also has a modest low temperature of melting, or 115 to 135 degrees Celsius, but polystyrene has a much higher, about 240 degree Celsius. Uh, okay, so the basic reactor for
Excuse me,
pyrolysis.
sir.
Yeah,
So I have a query. Like in the last diagram, so please put that.
yeah.
So, so in this, the carbon char pyrolysis and contractor, the arrow is showing both side. Like after the formation of carbon char, is there again pyrolysis is happening or what? I don't get it.
Sorry, what is your question? Can you please repeat?
Yes, sir. Actually, at the direction of arrow is from pyrolysis to carbon char and pyrolysis to contactor again. So, what's the meaning of this? Like, what's happening? Like, carbon char is again going for contactor or what?
So basically, carbon char is the solid residue after the
Yes.
pyrolysis. So whenever you carry out a pyrolysis under inert atmosphere, you will be getting a solid residue. You'll be getting some part as in the liquid form. You'll be getting some part in the gaseous form. Now, depending upon the pyrolysis reactor temperature, it might happen that under those conditions, solid liquid part are in the gaseous phase depending upon the temperature, but there will be always some solid part will be there, which is the char. So it is directly the pyrolysis, there is the char is there, which is the residue.
Yes, sir. I know that this is
Hmm.
residue of carbon char,
Yeah, yeah.
but again the arrow is upside towards contact.
This
What
is
that
the
means?
this is the gas and liquid part. The and liquid part. Okay. Did you get my point? Hello. So basically from the pyrolysis, the gas liquid mixture is fed into the contactor unit, and the solid part is directly obtained as the carbon char, which might be used as formation for the formation of different carbon based products, or might be used in the soil, or as a fuel, like those kind of applications are there. So moving ahead, I think I am clear. So moving ahead.
Also, my laptop got off. Can you please explain, please? Sorry, sir.
Yeah, so my point is this particular arrow through the contactor, which is going to the distillation unit, is for the gas liquid mixture. Okay, and then
Okay,
in the
sir.
distillation unit, depending upon their volatility, uh, they are basically you know differentiated through various fractions. So this particular part is for the gas, carbon char is the solid part. So that is the difference. There is nothing to worry about. The carbon char is again fed to the contactor. Nothing like that. These are two different product streams from the pyrolysis. And you see the
Okay,
gas I was telling, the gas is again obtained from the distillation unit, which is actually in the gaseous phase. This is again fed back to the pyrolysis reactor, recycled back, so that you get a high energy efficiency. Okay.
okay, sir. Thank you.
The different reactors are basically which are used for pyrolysis. One such reactor is the batch of semi-batch reactor, which has the advantages, certain advantages and disadvantages, and it works on the basis of at the temperature range of 300 to 800 degrees Celsius. You can see a basic pictorial view of this particular batch of semi-batch reactor, where you give the inlet gas, nitrogen, pressurize it, close it, then let the reaction happen, and then it take out your outlet gases. The Apart from the batch reactor, there is a fixed bed reactor. Fixed bed reactor is usually a continuous phase reactor. So in this, there is a catalyst on support is provided inside the fixed bed. The catalyst is usually in the pelletized form, and it's packed in a static bed. So it's a continuous process, and it's usually a less The disadvantages of fixed bed reactor uh, are basically the available surface area of catalyst is to be accessed by the reaction is limited. So this is one of the challenges for the fixed bed reactor to make more and more active sites and to make more accessible surface area of the catalyst for the pyrolysis reaction. And also fluidized bed reactor is also there. So where the catalyst sits on Yeah. So the catalyst sits on a distributor plate where the fluidizing gas carries this in a fluid state. So the reactants are provided from the bottom to make the catalyst and sand in a fluidized motion. Then the fluidized pyrolysis basically happens in the temperature range 850 degrees Celsius, and the products we get uh, from the top. Apart from that, there are also some other typical types of reactors like screw reactor, conical spouted bed reactor. Those are also there. So these are very typical types and obviously not very much highly available in the typical commercial purposes. So researches are actually ongoing in this kind of innovative reactor designs. Some basic international and national scenario are shown here, which are the different companies are there and different technologies, such as in Indian scenario, there is the IIP Gale technology is one of the most famous one. And the different catalyst types are also very important. Like for catalytic pyrolysis, the type of catalyst. So the shift towards a particular product for such as if you want the aromatic rich liquid hydrocarbons, there will be a certain type of catalyst required. If you want the gasoline will be the majority in our product, there will be certain. Or if you want a diesel, there will be. So this kind of catalyst types will be important for that. This kind of the catalysis people or chemical reaction engineering people are doing plenty of research. And after some typical data are basically shown the different properties of the gasoline obtained from waste plastic because what kind of product you are getting, this has to be also comparable with the commercial gasoline which is there in the available in the the petrol pumps and all for as a fuel. So these properties has to match so that fossil fuel from this kind with this kind of waste to fuel converted products. Okay. Such similarly as the gasoline, the typical diesel properties are also shown here, and you can basically see that these are very well matching with the Indian diesel specifications. The diesel obtained from waste plastic, similar to the gasoline also. Same things about the aromatic leach liquid products and certain of a typical plastics of the Signer plastic. Plastic is basically a company which wants to commercialize this particular pyrolysis and distillation technology to convert. So they had their uh, first full-scale plant in 2008 as early as then, and they try to produce a synthetic fuel from this particular waste plastics. So this kind of case studies were briefly discussed with the are there and what kind of challenges are associated with this type of feedstocks. Okay, and obviously the if you see the outputs, each ton of plastic produces approximately 700 liters of diesel, 100 liters of kerosene, 200 liters of light oil, and the residual char. about 5% of the output. So let us see some more questions. So which of the following not true about batch or semi-batch reactor? Easy to control process parameters, simple design, easy for large scale operation, higher labor cost per batch. So yeah, C is the correct answer. So batch reactors are not easy for large scale operations. For large scale commercialized operation, usually the continuous phase reactors are very much preferred. So other, it is very much easy to control the process parameters. It has some simple design. So these are the some advantages, but it is obviously has some difficulty in separating the catalyst. It has a higher labor cost, and also it is not very much easy or very much feasible for large scale operations. Which of the following reactors can be used for the plastic waste pyrolysis? Batch or semi-batch reactor, fixed bed reactor, all of the above. So as discussed, basically these are the all the types of the different reactors which can be used for plastic waste pyrolysis. So we are not talking about directly the commercial operation or something like that. Just talking about if they which are the reactor which can be used for pyrolysis. Basically, all of these are types of reactors. All of correct answer. So you have to identify this one example of reactor which is used for the pyrolysis of plastic waste. Is it a screw reactor, a conical spouted bed reactor, fluidized bed reactor, or none of the above? So the correct answer is the conical spouted bed reactor, one type of reactor which has basically the advantage of good mixing with its ability to handle large particle size and differences in particle density. On the top, you give the feed and you give the inert gas from the bottom, and this is the main reaction happening, and you get the products from this kind of side stream. However, these are little complicated design, and it has uh, different this kind of challenges during operation and catalyst feeding, entrainment, all those things. So as I told, these kind of reactors are all applicable in the commercial purpose. In the research zone, these are getting famous. So more and more research are happening, and more improvement in terms of reactor design are occurring nowadays. The last set of lectures will come here. Basically, the last two lectures were uh, basically covering the gas cleanup set things. So the contents were like the gas produced from different routes, processes for removal of unwanted elements of gas, different particulate removal techniques like gravity settler, ESP, bag filter, cyclone separator, gas molecules removals, some via absorption, adsorption methods, and removal of specific gas components. So we'll quickly go through the, these things. Composition, if you see, uh, there are different techniques like incineration, gasification, pyrolysis, anaerobic digestion. So there are multiple gases like CO2, NOx, SOx, H2S, hydrocarbons. There are these, and from them, uh, for different gas streams, we need to remove different elements, right? Such as NOx, SOx, PM, CO2 from incineration-based gases, from gasification like syngas. If you want to have the syngas as a pure component, so you as the as your main constituent gases. So you need to remove CO2, H2S, particulate matters, all those things. So similarly with the other pyrolysis, like you need to remove the CO2, HCl, dioxins, right? And if you talk about the different processes, so the gravity settlers, cyclones, electrostatic precipitator, filters, these are different particular processes which remove elements from the gases. Okay. Uh, so gravity settler. So these are like different itself. There are very much detailed, mechanical operations. I'm not going into much detail about these things, but based on the gravity, basically the as the name suggests, how the different particles, different materials are separated. That is that is carried out in the gravity settler. So the large abrasive particle. Large particle means this might have a greater mass, so they will be settled down, and the light particles will go out. So based on this kind of principle, so basically it's a very simple technique, low maintenance technique, and also it comes at the cost of low efficiency also. Okay, so some basic mathematics if you see, so the force balance you need to do. So you need to balance the gravity force and the drag force and the buoyant force. And from that, you need to calculate the terminal settling velocity. Based on that, you'll get that which particle will get settled down and which one will not. Similarly, the electrostatic precipitator is another type of arrangement where based on the electrostatic principle in charges, you want to separate uh, different particles. So which one is having a negative charge will be going towards this particular positive electrode, and which one is having a positive charge will be attracted towards this negative electrode. So based on that, these are the collecting electrodes, and in based on this mechanism, this electrostatic precipitator uh, works. Okay. There are two types of electrostatic precipitator also. The parallel plate electrostatic wear and pipe precipitator. You might check in internet. These are the detail. There are detailed information available with of this particular different mechanical operation techniques. Okay. And there are some basic calculations to calculate the efficiency. The efficiency eta is actually denoted by 1 minus drift velocity into collector surface area divided by the volumetric flow rate. Uh, so this particular formula is actually very important. In fact, like one problem we'll also discuss, which will be based on this particular formula also. Okay. And some further calculation to get different correlation between this kind of collect surface area and so this kind of different correlations you might also be interested to check and carry out some basic, you know, derivations. So you see a problem based on this. Uh, Based power plant is emitting 36,000 meter cube per hour flue gas. It is proposed to install an ESP with a collection efficiency of 95.5%. Calculate the total area of the collection electrodes. 146, 206, 333 or 444. So one hint is that like you might not get the exact answer, but at least you near to the options given and based on a recent uh, formula we discussed. So just the formula we discussed. Basically, efficiency is equals to 1 minus e to the power minus drift velocity into AC divided by Q. So here in the question, drift velocity is actually not given. So I have taken it as 0.13. In your examination or actual assignment aim, there must be drift velocity value. So just putting the values like Q is the flow rate of the flue gas. So need to convert the flue gas flow rate from meter cube per hour to meter cube per second. So divided by 3600, it get as 10 meter cube per second. And AC is the area we need to calculate. Here efficiency is given as 95.5%. So 0.955 equals to 1 minus e to the power minus 0.13 AC. Simple, if you solve it, then I'm getting it as the area around 238.46 meters, yeah, meter square. So the nearest answer is about 206. So 206 will be the correct answer. Again, this particular value would be depending on the drift velocity. So I think the drift velocity, exact drift velocity based on that particular value, you might get the exact value of the collection electrodes. Okay. So the last lecture, it basically covered some more techniques, basically the wet scrubbers. So the basic function of wet scrubbers is to provide a contact between scrubbing liquid, which is usually a water, and the particle. So there are different types of wet scrubbers are available, like spray tower, centrifugal scrubber, venturi scrubber, packed beds, and plate column, like that. Okay. So the basic advantages and disadvantages you might also want to check of the wet scrubbers. And scrubber is also another important parameter, or sorry, important technique for the gas cleaning section. Okay. And so the apart from that, so these are basically the all the different types of the uh, glass cleaning techniques which we have discussed. Some one or two further problems are there which I'll discuss in the next class. Along with that, we'll move into the next topic. Okay, so that's all from my side today. Thank you for joining.
Thank you, sir.
Thank you, sir.